Hipsters will be able to write and graph. Equations. If only given 2 points. So this is going to be a little bit different than what we've done before, because when we've done before, every time I gave you a set of points in a XY chart, I always gave you the y-intercept. The problems that we're going to see today, they're not going to give us the y-intercept, so we're going to have to find a way around that. We're going to talk about 2 different ways to work around that. One of them is kind of more of an estimation, and one of them is a precise answer. So we can start with this first way. We're given the 2 points, 2, 5, and 4, 8. So I'm just going to throw them in an XY chart. And we can definitely find part of this equation already. Thinking about y equals mx plus b, we can already find the slope. So I'm going to go ahead and start by finding the slope. Most of you should be able to do that. You did that already in your Do Now today, so you might actually be working a little bit ahead of me here, finding the slope. So I'm going to find my change in y and my change in x. Change in y looks like an increase of 3. My change in x looks like an increase of 2. So this is actually all I really need to help determine my slope. My change in y over my change in x is 3 over 2. So for my equation, my slope is 3 over 2x, but I don't know my y-intercept because I don't have any points down here that tell me 0, whatever. So I am missing this point right here, so we've got to find a different way. The first way is really kind of a way of just estimating it. I can actually just graph these 2 points, and if I graph the 2 points and draw a line through it, I can just see where it's going to cross over the y-axis. So I'm going to take this and I'm going to graph it. My point 2, 5. And my point 4, 8. And if we want this to be as precise as possible, it's not going to be perfect, but I'm going to want to go ahead and grab a straight edge to draw my line. If I don't have a straight edge, I'm not going to be able to graph this particularly straight, which means it's going to mess up my estimation, because when I'm looking at this, I'm going to be relying on where I see my line go through the y-axis to determine what my value should be. So here I am trying to draw a straight line as possible. And so I'm going to use this, and I'm going to look into my line. I'm going to say, hey, where does this cross through the y-axis? And hopefully your line is a little bit straighter than mine, because mine looks like it goes somewhere between 2 and 3, but hopefully on your own papers you have a straighter line that goes through the y-axis. And I'm seeing some people who have drawn some really straight lines telling me and showing me that they see that it goes through the y-axis here at 2. Now, as you can see, because I wasn't able to draw a perfectly straight line, that's why this is really just kind of an estimate. It's not perfect. And if we need a perfect equation, then we need to do something different, all right? So what we're going to do, we're going to come over here to the other way. We're going to do this differently. We're going to start with the same 2 points, 2, 5, and 4, 8. And I'm going to start the same way. I'm going to do the part that I know. I'm going to find the slope. So it's the same thing here. Find my change in y over my change in x. Change in y is 3 over 2. So I know, again, that my equation is y equals 3/2 x plus something. Now, again, we already know what that something is, but we've got to find a way to find exactly what it is, considering our graph was a little bit imperfect. So if I want to know exactly what it is, this is what we're going to do. We're going to go way back to when we learned about this general form, y equals mx plus b. And what it tells us is that given a slope and a y-intercept, every xy pair that's on that line is going to make that equation true. So that means that if we take this, y equals mx plus b, if we have the same slope, the same y-intercept, every x and y that's on this line is going to make that true. So let's go ahead and plug in the information that we know. Well, we know this is the slope, so that's our m. So we can plug that in as y equals 3/2 x plus b. And we know 2 points already, 2 pairs of x and y that are going to make this true. Those are the points that are given to us. So I can actually plug those into the equation. I'm going to take this 2 and I'm going to plug it in for x, because this is in my x column. So I'm just taking that 2 and I'm plugging it in for x over here. Oops. So times 2. So 3/2 x. And I'm going to take its y partner. Over here is 5, and I'm going to plug that in for y. So all I've done here at this point is I've plugged in the 2 values that I know. And I don't know b, and that's kind of the whole point here is I'm trying to figure out b. So I'm going to have to bring that down as a variable. All right, so all of that aside, this now becomes a really nice, hey, this is a one-step equation that I can solve as soon as I simplify it. So what can I do to go ahead and simplify this equation so far? Danilo?
You can cross multiply.
Yeah, we can multiply. So in particular, I can multiply, that's going to give me 6/2, or I can cross cancel first, either way. That's going to give me 5 is equal to 3 plus b. So all I've done is I multiplied this to simplify. Well, this is a super easy equation. This is one that you can do without actually doing the inverse operation, but just to make sure that we know how to do this inverse operation, somebody with a raised hand, what is the inverse operation I would do to solve this equation for b? There's one person with a raised hand who knows how to solve this equation. Oh, good. There's more of us now. LaShawn, how do I solve this equation? Yes, you do. I am going to wait until you tell me how to solve this equation.
Is that 5?
We have 5 is equal to 3 plus b, so we need to get that 3 away from the b. So we have to do the inverse of adding that 3.
Oh.
The opposite of adding 3. Subtract 3. You know I don't really like that word, so I'm going to add the opposite of 3, which is a negative 3 to both sides. So negative 3 plus 5 is equal to 3 plus negative 3 plus b. And the reason that works is because this adds up to 0, which is not consequential to this particular equation. So I get that b is equal to 2. Kip yes or kip no. Was b supposed to be equal to 2? Yeah, and that's what we proved with our first way that we did it, which was the graphing method. Now, unfortunately, like we showed, the graphing method is not perfect because it relies on you to draw a perfectly straight line perfectly through a pair of perfectly graphed points. That's a lot of perfection necessary to get a perfect answer. Not to mention, sometimes it's not going to go directly through one of the points. It may be a decimal, so it may be between 2 points, in which case there is no way for us to know exactly what it should be. So we're going to see a couple examples that are going to tell us exactly what it should be. I'm going to So looking at this, I want to give you a couple of, or how I would strategize being able to write a problem for this. So for me, I'm going to start by giving myself some units here. Units for my y and units for my x. So one thing that I might do is I might say, this is going to be y miles and x hours. So it's kind of like a speed here. So what that tells me is that if my units are going to line up correctly, that this needs to be hours on my rate and miles on my rate. And then if those things are going to add up, this should be 2 miles already. Okay? So what I know is that I've got to write a word problem that has the rate of 3 miles for 2 hours and has a starting point of 2 miles. Okay? And so then I should be able to develop a problem from there. So I usually, when I write my word problems, because it makes the most sense to me, I start by explaining the situation and the starting point. So I'm going to come over here, and I'm going to start by saying, LaShawn.
Nope.
Yep. LaShawn is 2 miles
Too much.
away from her house. Already. LaShawn is already 2 miles away from her house. She continues to walk away from her house.
Wait.
She's running away from home. Except she's walking. She continues to walk away from her house. And this is making sure that I'm linking this up correctly. I know that I'm increasing my miles here. So that means she needs to be walking further away. So she continues to walk away from her house at 3 miles every 2 hours. This is where it's clear to me that she's not really working very hard to get away from her house because she is walking really slow. All right, so this is where I have pretty much all of the pieces of my word problem already written. I have my rate, 3 miles over 2 hours, and that matches up to the rate in my word problem, or in my equation over here. And I've got my starting point, which is 2 miles in the equation. So the only thing that I need to do really here is just wrap it up really quickly and saying, write an equation to represent how far away, and I'm going to just kind of in parentheses, I'm going to put that there as y, how far away y LaShawn is after X hours. So notice my strategy there. My strategy was to give some units to my X and Y. Go ahead and label all of my units on my equation. And then I go through and I start to form my story. That's how I go about doing it. So what I actually want you to do in order to practice this is I want you to take, obviously, this exact same equation, come up with your own units and label your own units over here on the left-hand side, and then write your own word problem. Okay? Over on this left-hand side, you're going to come up with your own units. your own word problem here. So go ahead and take your units, label your x and your y, label the different parts of your rate, label the units on your starting point, and then write your word problem. I'm going to give you about 4 minutes to do this.